Let's start with the first chapter in engineering mathematics, that is linear algebra. In this chapter, I will cover the various topics, including the basic fundamental of the matrix, where we will be talking about the various types of matrix and basic matrix operations. Next important topic from the gate point of view is the rank of matrix. Then we'll talk about the solution of linear system of equation. Then we have eigenvalue and eigenvector. And the Cayley-Hamilton theorem. So let's start with the basic. What is the matrix? As we know, matrix, any matrix A can be represented as A11, A12, A13, A1n. Similarly, second row can be written as A22, A23, A2n, AM1, AM2, AM3, AMN. So here we can see this is called the rows, second row, similarly mth row, and these are called the columns of the matrix. So the general notation of any element is given by Aij, where I represents the row and j represents the column. So A23 represents the element which is in second row and third column. We have the various types of matrices. First is row matrix. Row matrix is nothing but a matrix which has one row only. Let's say, for example, this. So it contains only single row. That's why it is called the row matrix. So in this we can see it has one row and four column. So order of this matrix can be written as row into column. So 1 by 4, and here number of row is 1. That's why it is called the row matrix. Similarly, the next one we have is column matrix. So in this case, we can see it may contain any number of rows, but it has only one column. So in this case, this matrix has 3 rows, one column. So order of the matrix is 3 by 1. And since it contains a single column, so that's how it is called the column matrix. The next type of the matrix is the square matrix. And as the name suggests, square means the length and the width is equal. So in terms of matrix, when the number of rows and columns are equal, then the matrix is called the square matrix. So example can be written as 4, 5, 6, 7, 8, 9. So it contains 3 rows and 3 columns. So the order of matrix is 3 by 3. There is one term associated with the square matrix that is called principal diagonal. It is also called main diagonal or leading diagonal. And it is nothing but, as we consider the previous example again, so the element from the top left to the bottom right, these elements are called the principal diagonal of the matrix, of the square matrix. The next term is called the trace of the matrix. And it is nothing but the sum of diagonal elements. The principal diagonal is referred as a diagonal only here. As you can see, this element is A11. The second element here is A22. Here it is A33. So the diagonal elements can be represented by AII. So in the mathematical notation, we can write trace of a matrix which is represented by TR. Let's say, for example, matrix is A. Then trace of the matrix is nothing but summation of A11 plus A22 plus A33. Since it is 3 by 3 matrix, if it is n by n matrix, then in a generalized way we can write I is equal to 1 to n AII. This is called the trace of the matrix. There are certain properties of the trace of the matrix. Trace of lambda times of A, where lambda is a scalar and A is the matrix. Is nothing but lambda times of trace of A. Second property is trace of A plus B, summation of two matrix, and the trace of that matrix is nothing but trace of matrix A plus trace of matrix P. And the third property, trace of matrix AB, it, it is nothing but trace of matrix PA. Although one important thing to note here is the product of two matrices may not be equal to the B times of A, but the trace of these two matrices will be the same. Now again go back to the types of matrices. So the third type of matrix is the rectangular matrix. So here I is not equal to j, means number of rows is not equal to number of columns. Then it is called rectangular matrix, and the example can be written as 1 2 3 4 5 and 6. So it has two rows and it has three columns. So the order of matrix is 2 by 3. These are not equal, so that's why it is called the rectangular matrix. The fourth type of matrix is called the diagonal matrix. It is nothing but a square matrix in which all the elements are zero except the diagonal elements. And the diagonal element can be negative or it can be positive or it can be imaginary number also. So here we can see all the elements other than the diagonals are zero. So that's why this matrix is called the diagonal matrix. Next is scalar matrix. It is a particular type of diagonal matrix in which all the leading diagonals are same. And the example is 2 0 0 0 2 0 0 0 2. So here we can see it is a diagonal matrix, but all the diagonal terms are same. Then it is called the scalar matrix. The next is unit matrix, or it is also called identity matrix. In this, all the diagonal terms are 1 and it is represented by I. One thing to note here is, as if we multiply any number with 1, it doesn't change. Similar to that, if we multiply any matrix to I, then the matrix is going to remain same. The next type of matrix is null matrix. And as name itself says, it's null means all the elements are zero. So null matrix, the order can be anything, but the important thing is all the elements will be zero. The next type of matrix is the symmetric and the skew symmetric matrix. So in the symmetric matrix, Aij is equal to Aji. And in other words, it can also be written as A transpose is equal to A. And the skew symmetric matrix can be represented as Aij is equal to minus times of Aji. In other words, A transpose is equal to minus A. So before going to that, we need to understand what is A transpose. A transpose is nothing but conversion of row into the columns and column into the rows. Let's say, for example, transpose of the matrix. Let's consider this example 1, 2, 3, 4. Then the transpose can be written as 1, 2, 3, 4. So you can see this row is represented here and this row is represented here in the form of column. So in the symmetric matrix, the example of symmetric matrix, again I am going back to this symmetric matrix example. So here if I take any number 1, 3, 4, then in order to make it symmetric this element should be 3. Here this should be 4, 5, 6. So what symmetry says, if I take this diagonal, then about this diagonal, this term and this term should be same. This term and this term should be same. This term and this term should be same. So if I take the mirror image about the diagonal, all the elements should be same, then it is called the symmetric matrix. And example of skew symmetric matrix is so here one thing to note, all the elements, all the principal diagonal of the skew symmetric matrix should be 0. This is the most important thing here. All the principal diagonals should be 0. And if you take the mirror image about this, then 1 is becoming minus 1 over here, 2 is becoming minus 2, and minus 3 is becoming 3. And that's what it says, Aij should be equal to minus times of Aji. Next type of matrix is triangular matrix. In the triangular matrix also, first is upper triangular. Upper triangular matrix is the matrix in which elements below the diagonals are 0. So let's say for example A, B, C, D, E, F. So below the diagonal, you can see below this diagonal, all the elements are 0. So that's how it is called the upper triangular matrix. Similarly, lower triangular matrix. The matrix in which elements above the diagonals are 0. A0 0, B C 0, D E F. So in this case, elements above the diagonals are 0 and it is called the lower triangular matrix. The next type of matrix is the orthogonal matrix. if any matrix A and its transpose, if this will be equal to a unit matrix I, then the matrix is called the orthogonal matrix, and it should be equal to A transpose into A. The next matrix is the singular matrix. If determinant of any matrix is 0, then it is called singular. Then it is called the singular matrix. The next type of matrix is Hermitian matrix. And before going to Hermitian, we need to understand unitary matrix. What is unitary matrix? Unitary matrix is defined by A theta, and it is nothing but A bar transpose, and bar is nothing but the complex conjugate. So it is nothing but transpose of a conjugate of matrix A. And it can be said that since the conjugate term is used here, it means the matrix element consists of complex number here. So let's consider one example. Let's say, for example, A is nothing but 1 plus I, 3 plus I, and 2. So in this, the first thing what I need to do is to take the complex conjugate of this matrix. We'll do one by one, step by step. So A complex conjugate, it means we need to take the complex conjugate of each term. So the complex conjugate of 1 plus I is 1 minus I. Complex conjugate of I is minus I. For 3 plus I, it will be 3 minus I. And since it is a real number, so it will remain same. And if I take the transpose of this, then I can call this as A theta. So A theta is nothing but transpose of this. So 1 minus I, 3 minus I, and 2. So this is just example which I have shown to let you know what A theta means. But the example of unitary matrix is nothing but A theta into A, or otherwise A into A theta. When this will be equal to I, then the matrix is called the unitary matrix. And the example of the unitary matrix can be given as A is equal to 1 plus I by 2 minus 1 plus I by 2, 1 plus I by 2, 1 minus I by 2. So if you take the complex conjugate of each term, all the four terms are the complex, and after taking the complex conjugate, if we take the transpose, then and if we multiply with the original matrix A, we should get unit matrix. Then it is called the unitary matrix. Next type of matrix is Hermitian matrix. So when Aij is nothing but equal to Aij complex conjugate, then the matrix is called the Hermitian matrix. In other words, it can be written as A theta is equal to A, and we have already seen what is the meaning of A theta, means A bar transpose. If this will be equal to A, then the matrix is called the Hermitian matrix. So here it should be A bar Ji. And the example of the Hermitian matrix is 5, 1 minus I, 1 plus I, 5. If this is the matrix, then I need to take the complex conjugate of this matrix, which will be nothing but 5, 1 plus I, 1 minus I, and 5. And after this, if I take the transpose of this, it will be 5, 1 plus I, 1 minus I, and 5. And this matrix we can see is equal to A, and A bar transpose is called A theta. So in this case, A theta is equal to A. So the matrix is called the Hermitian matrix. And the one important thing here to note is in Hermitian matrix, all diagonal elements should always be real. Because if it would be imaginary part or a complex part, then after taking the transpose, after taking the complex conjugate, it can never become the same number as that of the original matrix.